So first, I want to introduce to you James Brown. James is the Executive Director of the STEM Coalition. By the way, the bios are on the back of the program, and you can refer to. James?
Thank you, Saeed. It's a pleasure to be here, and it's an honor for me as an engineer myself to be talking about engineering education. I sort of came to this field a little bit by accident, and Congressman Ryan will appreciate this a little bit. I'm here in a career in public policy because about 20 years ago, a member of Congress who I won't name tried to eliminate the scholarship program I was on. And all politics being local, it's a good way to introduce yourself to the public policy process. So I can see it both from a personal level and also from a policy level. So is this working? Okay, great. So this is who we are. The STEM Education Coalition is an alliance of a little more than 600 business, professional, and education organizations. So lots of groups that I'm sure are represented in the audience are members of our coalition. And we advocate for STEM education as a public policy priority at the national level, within federal legislation, and also at the state level. I'm going to set the stage for this conversation in a couple of different ways. The first is talking about public images around STEM and STEM careers. So if you poll the general public what they think about STEM or STEM careers, this is the image they associate with the STEM professional. The research scientist type person. They will define STEM in interesting ways. When you talk to the so-called person on the street, they'll say STEM is for me, science is for me, or it's not for me. There's very much this notion that STEM is a particular thing, that I either see myself as being a scientist or a scientist or engineer, some combination of those different words, or they don't. This is what Hollywood portrays as people in the science and engineering fields, right? This is a little bit of a dated image. You have to be old enough to laugh at this image, right? But this is traditionally what you see as the public images around scientists or engineers, and it's notable, right? It's the crazy white guy, right? This is an important part of the demystifying of the science and engineering professions. This is what a lot of students think about engineering in particular. I think there's like a 75% chance every one of those people is an engineer in that picture. That's what students typically have as an image within their library of images about careers within these fields. And if you look at what actual careers are today, they're enormously varied, right? The engineer is no longer the skinny black tie person. There are engineering careers, with computerized technology. They're in the field. Some people wear hard hats. Some people don't wear hard hats. They're in the lab. They're not in the lab. They have a tremendous diversity of different opportunities within the science and engineering fields and within the different disciplines within engineering. And it's important to notice, considering the image from Back to the Future, right? If you think about some of the recent images that portray scientists, engineers, professionals, these pictures are notable for a couple of different reasons. First off, in each one of these pictures, the person who was the enthusiast or the technology person or the astronaut, they were the leading character in the movies that they're portrayed in. They're portrayed as being pretty cool. I mean, that's a very different motif than what you sort of traditionally associate with science and engineering. The other thing I find interesting is so for the first two movies are connected. They've become so popular for people to be typecast in these type of roles being popular that the same actress, Jessica Chastain, plays the leader of both the person who saves the world in Interstellar, the scientist who saves the world in Interstellar, and the leader of the Mars mission. I just couldn't find a poster with her face on it. And then, of course, there's Sandra Bullock. And these are movies in 3 consecutive years. So it strikes me as being notable that you're starting to see a changing image of how science and technology careers are being portrayed. So a little bit about the overlay of engineering issues in 5 minutes. So the first thing I'll say is engineers do very well relative to the rest of the economy. This is not the top list of engineering professions. This is the top 10 highest paying college majors. So look at that list, right? Petroleum engineering, computer engineering, chemical engineering, computer science, aerospace engineering, mechanical engineering, electrical engineering, engineering technology. I didn't rig this list. This is the actual list. And so engineers do quite well when you do measures of whether, what the value they're adding both to the economy and getting from their education. This is a little bit distant to look at, but I wanted to show that there are about 80,000 graduates every year with degrees in engineering. And to put that in context, the science and engineering workforce is about 5.7 million people out of about 185 million people working in the U.S. economy. So that sort of gives you some context. And within that, engineering is about 1.5 million people working within the field we call engineering under Saeed's definition. And this just shows you the different disciplines. I happen to be a nuclear engineer. The career choice presented to me by my father, who is also an engineer, was choose which branch of engineering you like to go into. So nuclear engineering is the one at the very bottom on the right, so it's probably the least popular. There is a very distinct difference between the science and engineering workforce and the overall U.S. population. And this is a particular focus of public policy. If you want to grow the engineering workforce, you want to expand opportunity, you've generally got to look in areas that are underrepresented within the science and engineering disciplines. And engineering has its own demographics compared to other science careers, but there are issues with women being underrepresented in most engineering disciplines. Minorities and people from different economic backgrounds tend to be underrepresented in the STEM fields. Although there are some exceptions to that, that's not a across-the-board generalization. Generally, you want to focus your efforts to recruit people in the science and engineering disciplines on areas where they're not already represented. That's sort of a best practice within this field, and this is, of course, an issue with the rest of the STEM fields as well. So one of the trends that's driving engineering education are new standards that are being adopted in science. And that matters because these new science standards, the so-called next generation science standards, incorporate engineering and technology concepts for the first time. So if you're an engineering educator, you can show how what you're doing appeals to the new standards that your state has, and that helps drive the process of change within education. And engineering is a particularly focused field in terms of how people make career decisions. So the biggest selector for if you're going to be an engineer is whether your father was an engineer, and I'm a perfect example of that. But it sort of flows down from that. So the second biggest selector is if somebody in your family is in that career path. Then you look at mentorship relationships. Then you look at exposure within your school, and then finally at the end, it's people who found engineering from within their own. They discovered it on their own. Is the least. So it's not popular opinion that's driving people to these careers. It generally tends to be relationships that they have that open up what an engineering career field is. And Congressman Ryan made an important allusion to robotics competitions, which is what's at the top left of this slide. There's some interesting entry points into engineering that are emerging now, where competitions around STEM. And I can't think of anything that incorporates more engineering design principles than a robotics competition, where you are taking the motion of a ball through the air, and translating that from an equation that somebody might learn in their high school physics class into, if I can figure out how to get the ball in the hole, I'm going to win the competition. That analogy sounds an awful lot like basketball, right? So that's appealing to a notion of competition. It's appealing to sort of innovation and creativity for its own sake, not just because you're learning it on its own and independent from things that really young people care about. So Project Lead the Way is another example, and these are both members of our coalition, of doing hands-on learning at all levels of education being a really important attractor to getting kids into these career paths that they otherwise might not have access to. And then the last thought I would put on the slide here is alluding to something that Saeed raised, which is there is a federal ecosystem of agency roles that are involving engineering education and STEM education. The Every Student Succeeds Act has a lot of opportunity to improve STEM education outcomes and engineering career paths, because it provides a lot of flexibility for states to deal with these issues they didn't have before. And of course, that law touches directly on the mission of the Department of Education. The National Science Foundation is right there in terms of an agency that pioneers best practices, helps develop new understanding of the best techniques to use to get students into engineering careers. And then there are lots of other mission agencies that have engineering outreach programs or things of that kind, where they're focused on connecting careers to the missions of their individual agencies. So thank you very much, and we'll now move to our next speaker.
Thank you.